let's try a different example here. Let's say I'm creating a simple sum function. Yes, I know it already exists in Python, but we'll just create our own. A simple one that takes num1 and num2. And in here, we'll just return num1 plus num2. Now, if we were to just simply do sum1 and sum2, and I ran our program, well, let's print it out first. I click run. I get 1 and 2 because it just adds the two strings together. So let's just do this and click run. I get a type error. Must be string, not int. So based on what we learned, how do we handle this? Well, we can add a try block in here and wrap this function, or we can build it directly into our function. So I can say try this part, and here have an except clause that says perhaps if we get any type of error, we'll print something is wrong. If I run this, I get something is wrong. But here's the problem. By just doing except with no exceptions, as a programmer, I'm reading this and I don't really know what actually went wrong because it could be so many things. So a good practice is to always catch these errors based on a specific exception. This way, you know what the error is and you can be more descriptive. So here we can say type error, and this type error, we can just say, please enter numbers. So that if I run this, I get please enter numbers. So now, all right, my error is more descriptive. I should fix this and make sure that I enter numbers. Awesome. Now, a common pattern when doing error handling is to do something like this. Type error as, and then doing something like a variable. So whatever variable we want. In our case, let's just say error. So I'm saying, hey, if you catch type error, let us use error in our error message. So I can say here plus error. So that if I run, and let's do a string here. If I run, look at that. I get the error printed. Let me just open this up a little bit so you can see it clear. Look at that. It actually gives me the error that I want. So that I can see that on line 5, on this line, I get a type error, unsupported operand. And I get a descriptive error of what is happening. So maybe I could use it in my output message. But what if I don't want to use this and I do run? All right, everything is working. Again, if I do plus error and I click run, and this is actually tricky, but it says here, during handling of the above exception, which I'm doing, another exception occurred. Oh boy, I tried to handle something and I had an error within that error. So this is sometimes tricky, but what it means is what we get out here is actually an error object. It's a built-in exception in Python. You can't add in here the way I have. Instead, we want to use an F string. So I do F, and then here pass it the error. So that now, if I run this, I get please enter number, unsupported operand, type S for plus, int, and str. So I actually get this error available to me. Now, if I was to just print this error, let's see what it looks like. If I click run, you see this is the part of the error that we get. So it's very, very useful if you want to give meaningful errors to your users. Another interesting thing you can do is something like this, where you wrap these errors together. So let's say we have 0 division error as well. And here we'll just say, oops. If we, for example, divide num1 by num2, let's just run this first. I get oops. If I do 1 divided by 0 and I run this, I also get oops. So I can handle multiple errors the same way. I can also say as error here and just actually print out the error. And if I run this, I'll get division by 0. Or if I do a string and run this, I get the other error type. So this, again, is really useful to combine different errors if you want to handle them the same way. But what if we actually want to raise our own errors? That is, we want to throw our own errors. Maybe inside of this except block, I actually want the error to display for certain types of errors. How could we do that? Let's find out in the next video.